Good afternoon, all. This is Ramdas Kapla, Associate Professor, CSE Department, Narsima Reddy Engineering College. Today, we are talking about the topic subject called Introduction to AI, and today's topic is breadth first search, and it is a very important search algorithm, and it is uninformed search space. Let's talk in detail. What is breadth first search? Before going to further, let's talk about what is breadth first search. Okay, breadth first search is a graph traversal algorithm. It explores all nodes at the current depth level before moving to the next level. Useful for finding the shortest path in unweighted graph. Let's see the image. It's a simple graph which doesn't have any weights. The nodes are A, B, C, D, and F. If you see it up. Okay. And breadth first search always starts with, as we talked about the earlier, for searching space, first we need to find starting point has to be there, and we need to go to the solution. And here our requirement is we need to find the shortest path. So we started from the starting point called node A, and we visited all neighboring nodes. For A, for A, B and C are the neighbors. So we visited the nearest neighbors, all neighbors, and the current state before moving to the next level. And then we traversal from one level to the next level, nearest level, one after the other, neighborings from A, B, and C. From B, what are the next nearest elements? From C, from D, from E, so as F. In this example, the traversal sequence will be A, B, C, D, E, F. The arrows representing the traversal directions. If you see it up, the arrows representing the traversal direction, and the levels are clearly marked to show breadth first search. And what is before, let's take a step-by-step discussion about the BFS algorithm. We should have the queue should be, this follows, breadth first search follows queue. Queue means first in, first out. The element which comes first will be exited from the queue. First, we need to make sure that the queue is empty. Then we need to add the starting node into the queue, and then we need to remove the node from the front one after the other, and we need to visit all the nodes which are neighboring to that, and then we need to enqueue. We need to insert the elements, and then we need to remove the queue. These all process will be repeatedly has to be done one after the other until unless the queue is empty. Let's see an example here in detail. Okay, breadth first search explores the space level by level, starting from the root node, and it explores all the nodes at the particular level before moving to the next level. That's what breadth first search. First breadth it'll do, then it'll go to the next layer, then it'll go to the next layer, then it'll go to the next layer. That's what breadth first search does, and it follows queue algorithm. Complete search. BFS guarantees that all solutions, to find all possible solutions, will be there using space fetch, and it gives the optimal search. BFS basically give the shortest path and of all the nodes. Okay, if you see it up in the right side of the algorithm, right side, BFS first it will go to the root node 0, then it will go to the next level, first node, then follows by the second node, then third node, then it will go to the fourth node, fifth node, sixth node, and seventh node. That's what breadth first search does. And the applications of breadth first search are, it is used for finding the shortest path. Network routing. BFS is used in network routing algorithms to find the shortest path between two devices in a network and ensures data transformation. Data transformation will be done efficiently. And web cloning. BFS is also used to explore websites, indexing pages in a systematic manner, following first link after the other, first, second, then third, then fourth, then fifth, likewise. And BFS is used for finding the nearest algorithms. BFS is used in social networks, recommendation systems, and geographical mapping. These are the applications of BFS. And BFS explores the world of graph. It connects components. BFS used to connect one component to another component, one device to another device, one node to another node, directly or indirectly using BSF. Cycle detections. BSF is also used to detect the cycles in a graph, which are closed path where a node is visited twice. And bipartite graph checks will also will be done using BSF. And the implementation details are, it follows queue data structure, second visitor arrays, and adjacent list representation. This is where BSF will be implemented. And the conclusions are, BFS is a fundamental graph search algorithm with wide range applications in derived domains, from pathfinding and network to network communication, recommendation systems, and BFS empowers you to navigate and explore the world of graph effectively. Thank you very much. And we'll talk about depth first search in our next class, next session. Till then, have a good day.